Find the first 5 terms of the Maclaurin expansion for f of x is equal to ln of 1 plus x. Okay, first thing you might ask is why have we not tried to do ln of x? Well, ln of x is not valid when x is equal to 0, therefore it's not differentiable at x is equal to 0, therefore we cannot use Maclaurin's experiment to expand ln of x, but we can do 1 plus x. So suppose we write ln of 1 plus x as a plus bx plus cx squared plus dx cubed plus ex to the 4 fx to the 5, and we can find the values of a, b, c, d, e, and f. I'm going to use this GeoGebra app again, and I will put the link for the GeoGebra app in the notes of this video. So going to this GeoGebra app, here we have ln of 1 plus x, and we can actually here, you see, work out the derivative at this particular point. Okay, if we click, okay, we will see that the derivative when is equal to 0 will actually also be 0, because if you differentiate ln of, sorry, we don't need to differentiate it, sorry, if we have ln of 1 plus x and you put x is equal to 0, you're going to get ln of 1, which is 0, so that term doesn't exist, so it's not a good value to take. Now if we take n is equal to 1, then we get a slightly better approximation around that point. And if we work out f as 0, which we know to be 0 already, but f dash of 0 of x, this gives me 0. If you differentiate ln of 1 plus x, you get 1 plus x to the minus 1. Okay, so if you put 1 in there, you're going to get x, 1x. Okay, and that gives me a slightly better approximation. But we can make it better by taking n is equal to 2. The second derivative is going to be 1 plus x to the minus 2. Okay, and then when you put 0 in here, you're just going to get 1 over 2 factorial, which is going to be a half x squared. It's minus because when you bring down the derivative here, this becomes negative. When we take n is equal to 3, okay, so when you bring down minus 2, the thing becomes plus 2, because it's minus minus, 1 plus x to the minus 3. When you put 0 in here, you're just going to get 2 divided by 6, 3 factorial, which is going to be 1/3 x cubed. You can see that the approximation is getting better, and we will repeat for n is equal to 4, so it's getting even slightly better. We're going to get x minus a half x to the squared plus a third x cubed plus a quarter. You bring down the minus 3 times 2 gives me the 6 times 1 plus 0 over 2 factorial, which is x to the 4. And we can do x to the 5. So it gets slightly better. Unfortunately, the thing sort of gets in the way, because it's getting rather long. The next term will be minus 4 times minus 6, which gives me plus 24 when you put 0 in here to the minus 5. When you put 0 here, 1 plus x to the minus 5, it will become just 24 over 120, which comes down to plus 1/5 of x, okay? Obviously, with higher values of n, the approximation will get slightly better, but not much. Okay, so here we can see Maclaurin's expansion for ln of 1 plus x. What we can notice between this and other ones, that it's only really valid between minus 1 and 1. Okay, if you flip back through these, you can see it's not sort of proceeding. So this is not valid for all values of x. It's sort of valued for the x being between minus 1 and 1. Okay, not including them. Okay, underneath here we've got the general form for Maclaurin's series. Okay, so this GeoGebra app will be in the notes of the video. I hope you've understood, and I thank you very much for watching. Be careful about the validity of this expansion. Okay, it's something you need to be careful of. Okay, I thank you very much for watching.